Hello everybody, this is Cap here, and I would like to welcome you to another C++ containers tutorial. So in this video we are going to continue our discussion on Deques. But instead of looking at the member functions and whatnot, we're going to take a look at how it actually works in memory. So as you can see, I've created a Deque, and then I'm just going to get the address here. There we go. And then I'm going to add quite a few elements. Say 3, 4, and then I'm just going to copy those and paste them a few times because we don't really care what the elements are for this demonstration here. Okay, that should be enough there. So let's step into it. And get our address. Okay, this is what we're concerned with here because it points to, I guess you could say, our table, for lack of a better word. And plus it makes the whole concept a lot easier to understand if you can just think of this here as the table. And then we have that. Okay. So you can think of this as a table of pointers to our actual data. And this is why Deques don't have to reallocate and move nearly as much as vectors do, because it doesn't have to be contiguous. So really there's not much penalty for having this big of a table. As for with a vector, we would have to allocate everything that we needed, and then if we filled that, we'd have to reallocate even more and then move it. But with a Deque, since we use kind of this table type structure, whenever the allocated memory that this is pointing to, which is this, so you can see our 3 there. So once this gets down to here, we won't have to reallocate and move this. We'll just allocate another space in memory, put the pointer here, and use it. And then once our table gets completely full, then we would have to reallocate and move it, which you'll see as this table fills up here with pointers. So let's just step through this here pretty quickly. As you can see, this filled up here and is completely full, so it went out and allocated space elsewhere to continue putting elements in the Deque without having to reallocate this or this. Then we just kind of move along here. Ooh, I don't think I put in enough there. I didn't. Sorry about that. Here, I'll just... Whoops. Copy that. And paste it. And paste it. Surely that'll be enough. Okay. Okay, so here's our table again. Let's just go through and watch it fill up there. Okay. And as you can see, right there, it allocated new memory elsewhere, moved our table over to it, and then deallocated this. So as you can see, it takes a lot of elements before our deck has to move. So this table that we were seeing can actually be implemented in quite a few ways. You know, it can be a map of vectors or a vector of vectors or even an array of arrays. But regardless of how it's implemented, it usually looks something like this. We have a container that holds pointers. And these pointers point to chunks of memory that hold our actual deck data. Or elements, I guess you could say. And these chunks can be scattered all throughout memory. So when these fill up, you know, they're filled with integers and whatnot, all it has to do is go out in memory somewhere, find the appropriate amount of space, allocate it, and then store the pointer in our table here. Which means that it has to reallocate a lot less than vectors do. So I just kind of wanted to get through, you know, how it actually works in memory in this video. And there's also a method called resize that you can use to, I guess you could say, somewhat manage memory. Though it doesn't really give you as much control as we had over vectors. You know, we could come down here and say di.resize. Let's say 100. But this actually initializes all of that space. So it's equivalent to the resize in vector. If you resize it to this amount, it assumes that you're going to use that, so it automatically initializes it all. So it's not like the reserve in vector, it's, you know, just like the resize. So that's something to be aware of as well. And you can also do a resize 100, which would resize it to hold 100 elements. And you can also tell it what to initialize them to. So we could have it initialize all of them to 2 if we wanted to, or, you know, whatever integer we desire. So that's pretty much what I wanted to get through in this tutorial. If you like this tutorial, please let me know by hitting the like button. If you've seen a few of my videos and really like them, you can go ahead and subscribe so you can see when I post new ones. And I would like to thank you guys for watching, and I will see you in the next video.